Okay, we're on Chapter 1, Ingredients of Change on Functions and Limits, and this is Section 1.9, Quadratic Functions and Models. So quadratic functions form the third family of functions that exhibit only a single type of concavity over the entire input interval. Now, these differ from exponential and logarithmic functions in that they also exhibit a change of direction. So they're either decreasing and then they switch direction and become increasing, or they're increasing and then they become decreasing. So the quadratic functions are increasing over a portion of the unrestricted input interval and decreasing over another. And like I said, either they're going to be increasing at the beginning and then they change directions and then they decrease, or they're decreasing at the beginning, then they change directions and then they're increasing. Okay. And so the key thing is these are parabolas. That's the key quadratic function that we know about already, and that's how it would be, increasing and then decreasing, or decreasing and then increasing. Of course, drawings aren't very good there, but that's what we're looking at for the quadratic functions here. Now, a quadratic model is going to be in the form ax squared plus bx plus c. Now, a cannot be 0 because if it is, then we lose the quadratic part. And then b and c are just constants. And a will be a constant too, but it just can't be that 0 constant. Okay. Now, graphically, the graph of a quadratic function is either concave up for a parabola if a is greater than 0. So here, we have a greater than 0, and it's concave down if a is less than 0. So that's the key things. If our number here in front of the x squared is greater than 0, it's going to be concave up, but if it's less than, it's concave down. And these are better drawings of what we get for the concavity. Now think about this. This is concave up. This is concave down. So you have to think about it as the whole. And then we have increasing. It reached the max in this case, and then we go to decreasing. Here we're decreasing. We hit a minimum, and then we're increasing. Okay. Now, the behavior of the quadratic function. Well, for concave up ones like this, the function decreases to that minimum, like I said, and then it increases. And this is for a greater than 0. So our limit for x going either to plus or negative infinity, either direction for that whole, whatever the quadratic function is, whatever a, b, and c are, is going to be infinity. Because if you think about it, we just are going up, 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 and up, up, up. And so, no matter which way we go, we're just continuing to go up both ways. Now for the concave down, we're going down. So again, we're increasing to a max in this case, and then we decrease, and this is where a is less than 0. And if we think about this, the limit, whether x goes to positive or negative infinity, so if it goes this direction or it goes this direction over here on the right, both of them are going to negative infinity. Okay, so they're going to be the same for the end behavior, both directions, positive and negative. Okay. All right, so I'll stop there and then we'll start looking at some actual more things.